For the beam shown below with constant EI by double integration method, determine the magnitude of B so that letter A, the tangent at B is horizontal, and letter B, the deflection at C is 0. So here is the given figure. First, let's solve for the reactions, AY and RB. AX is 0, definitely not shown, but it's 0. So moment B 0 equals AY times 5.4 plus B times 1.8 minus 1 half of 5.4 times 30. 1/3 of 5.4 is 1.8. So simplifying and solving for AY in terms of B, AY is equal to 27 minus B over 3. Likewise, moment A0, so let's now have a sectioning, call that X, origin at A. Now, we can have up to here as section, but it will be complicated because we're going to extend this triangular loading and we add a counteracting loading, so it will be a lengthy equation. Instead, we plan to separate the differential equations for portion AB and for portion BC. So we will call this intensity W. So W as to X equals 30 as to 5.4. Therefore, W is equal to 50 over 9 of X. So that the differential equation for this portion is EI Y double prime AB or is equal to quantity 27 minus P over 3 times X minus 1 half of X times 50 over 9X times X over 3 for the moment arm. Simplifying, EI Y double prime AB is quantity 27 minus P over 3X minus 25 over 27X cubed. Then integrate. EIY prime AB is quantity 27 minus P over 3 X squared over 2. That's it. Then minus 25x to the 4th over 108 plus 0, plus C sub 1 rather. There is slope at A, but there is no C sub 2 because when x is 0, y at A is 0. Integrate again, AIY AB is equal to quantity 27 minus P over 3 x cubed over 6 minus 5x to the 5th over 108 x to the 5th plus C sub 1x. Again, there's no C sub 2 because when x is 0, y is 0. Then, boundary conditions, x is 5.4, y is 0. And for the given condition, when x is 5.4, the tangent is horizontal. So meaning to say slope is 0 or y prime AB is 0 when x is 5.4. So we begin with y prime 0 at B for this condition. Substitute here. So 0 equals 27 minus B over 3 over 2. 5.4 square minus 25 over 108, 5.4 to the 4th plus C sub 1. So C sub 1 is 25 over 108 times 5.4 to the 4th minus this value times 27 minus P over 3. So that would be 196.83 minus 14.58 of quantity 27 minus P over 3. Take note that C sub 1, which is equal to this equation 1, is established for the condition in the problem the tangent at B is horizontal, not the slope, not the deflection at B is 0. So the deflection at B is always 0 because this is a support. So for the condition deflection at B 0 into this equation, so 27 minus P over 3, 5.4 cubed over 6 minus 5 over 108, 5.4 to the 5th plus C sub 1 times 5.4. So this value, 5.4 to the 5th over 108 divided by 5.4 is, so C sub 1 is equal to 5 over 108 times 5.4 to the 5th over 5.4, that's 39.366. Then 5.4 cube over 6 divided by 5.4 is then transpose negative 4.86 quantity 27 minus p over 3, equation 2. So this is the value of C sub 1 regardless of this condition in the problem. So this is always the value of C sub 1 because we established this when x is 5.4, the deflection at B is always 0. It is only in equation 1 where we have this condition that tangent at B is horizontal. Without that condition, the tangent at B is always has a value, not horizontal, only for this situation. So equating equations 1 and 2, 196.83 minus 14.58 quantity 27 minus p over 3 equals 39.366 minus 4.86 quantity 27 minus p over 3. So 196.83 minus 39.366, then 14.58 minus 4.86 of 27 minus p over 3. So 157.464 equals 9.72 of 27 minus p over 3. So 157.464 over 9.72, then make it negative plus 27, then the answer multiplied by 3. That's the value of P. So P is 32.4 kilonewtons. Then we proceed to the second condition, that the deflection at C is 0. So for the first condition, for the tangent at B to horizontal, P is 32.4. And for the second condition, the deflection at C is 0. So we will establish differential equation of the elastic curve for portion BC by not extending it, by not considering one sectioning only, but rather we have to establish EI y double prime BC. So if this is x from the origin, then this distance is 5.4 plus 1.87.2 minus x. Since if you consider from the right, counterclockwise moment is positive, so clockwise is negative. So therefore EI y double prime BC is negative p times quantity 7.2x. Integrate EI y prime BC is equal to positive because this is 7.2 minus x, so the integral is negative, 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 so it becomes positive. P over 2, 7.2 quantity 7.2 minus x squared plus c sub 3. There is also c sub 4 because the origin is here, that's the right part. Integrate again, so EIY BC is equal to P over 6 quantity 7.2 negative. Interchange, so negative, the integral is negative because this is 7.2 minus x. The coefficient of x is negative 1, not positive. 7.2 minus x cubed, so negative p over 6, 7.2 minus x cubed plus c sub 3x plus c sub 4. So we can evaluate c sub 3 and c sub 4 because there are two conditions. One, for the fixed condition that deflection at B is 0 when x is 5.4, and deflection at C is 0 for this condition in the problem. So 0 equals negative p over 6 times quantity 7.2 minus 5.4 at B cube plus c sub 3 times 5.4 plus c sub 4. So 5.4 c sub 3 plus c sub 4 equals 0.972 p. Call that equation 3. Then x is 7.2, yc is 0, the condition in the problem. So the first term would be 0, then c sub 3 times 7.2 plus c sub 4. C sub 3 times 7.2 plus c sub 4. So that means because this is 0, c sub 4 is negative 7.2 of c sub 3. Substitute in equation 3. 5.4 C sub 3 plus negative 7.2 C sub 3 equals 0.972. So from here we can solve C sub 3, negative of 0.54 of P. And C sub 4 is negative 7.2 of quantity negative 0.54 P. So C sub 4 is 3.888 P. Then slope at B is common for AB and for BC. So that's the third equation that we should establish. So we use this, x is 5.4, and equate it with this equation when x is 5.4. C sub 3 is already known. But the value of C sub 1 here that will be used is the value of C sub 1 when deflection at B is 0, not by the deflection at B is horizontal, because it was in part A. This is already part B. In part B, it is the deflection at C that is 0. The slope at B is no longer horizontal for part C, for part B. So again, the value of C sub 1 is this value here, because this value of C sub 1 was established when the deflection at B is 0 from this equation here, which is this. So x is 5.4. So 27 minus P over 3 over 2 times 5.4 square minus 25 over 108 times 5.4 to the fourth plus C sub 1, which is 39.366 minus 4.86 quantity 27 minus P over 3, then equals here P over 2 times 7.2 minus 5.4, so 1.8 square plus C sub 3, negative 0.54 P. So combining the constants and the term with 27 minus P over 3 from the left side of the equation. So 9.72, 27 minus P over 3, and the constant, negative 25 over 108 times 5.4 to the fourth, then plus 39.366. That's negative 154.464. And the right side, 1.62p minus 0.54p. So simplifying further, 104.976 minus 3.24p, combine the constants, and simplify 9.72 times negative p over 3, that's negative 3.24p. And the right side, 1.62 minus 0.54p is 1.08p. Therefore, P is 104.976 divided by quantity 3.24 plus 1.08. So from here, we can now solve for P. P is equal to 32.4 kilonewtons. No, 23. So P is 24.3 kilonewtons. So 24.3 kilonewtons. That's it.